So this part of our discussion is going to be about how to read regressions. And this is something you're going to come across frequently in academic journal articles. And so we just want to get a lay of the land so you know what all those numbers mean, not how to do it specifically. Okay. So we were looking at correlations before, and we know that the world is much more complex and that there's other confounding variables that might influence both the dependent and independent variables. So all of these confounding variables is why we need multivariate statistics. So where we're moving from just 2 variables into more than 2. One of the most common ways that we can do this is with regression analysis. And I make a note, you can do regression with 2 variables, but commonly you'll see more than just 2 variables. So the way you can imagine regression is kind of like a multi-dimensional correlation. You can kind of see how that would work in 3 dimensions, where you have like a 3D with 3 axes, and the points are like suspended in the air. And then once you get past 3 dimensions, you really have to just suspend your disbelief for a moment, because it's really hard to think in 4 dimensions because, we don't do that. Okay, so in math speak, here is the regression formula. So y equals a plus b1bx plus b2bx over and over and over plus e. Okay, so a here, this is the intercept, so where the line crosses the y-axis down here. B is the slope line, so the slope of the line, of the regression line for that variable. And then E, sorry, B is the slope line, the line of the slope. Okay, I'm not going to make fun of myself. All right, E is the error term, so all the stuff that doesn't quite fit into the line. So let's go back to that example of the relationship between wealth and the quality of elections. So I predicted that higher wealth in a country would lead to better quality elections. It's based on this Lipset hypothesis that more resources means more people will want to participate in free and fair elections. You turn that conception into a measure, so GDP and PEI index. We create a scatter plot, and we know that there's a positive correlation. We did this before, but then I'm like, well, wait a second. There's some confounding variables we need to take into consideration. Region of the world, the quality of democracy more generally, and regime durability, or how long something's been democratic. And for this, I would, or a scholar would, include these control variables in a regression. And this is the output that you might see in a journal article. Okay. So I'm going to show you essentially how to read this and to at least know what all of these things are, so that you can, when you see it in a journal article, you can see, okay, I know what each of these things are. All right, so let's just move over. Here are the things we're going to want to take a look at. I'm just going to copy this over here just so that I can remember what it was that I have to show you guys. And I'm going to kind of show you color coding what everything is. Ooh, okay, so let's just make this all bigger. Boop, 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 boop. Just give me a moment. Okay, wait, okay. So first of all, so you'll notice here that we have, actually let's start right here. This is your dependent variable. So we said that the thing we're interested in looking at is, ooh, shape outline. Yeah, it's good, shape fill, no fill, there we go. So the thing that we were interested in looking at was whether wealth influences perceptions of electoral integrity. So usually at the top, you might just have a number if it's just a model number, but I always like to give people what is the dependent variable, essentially. And now we look for our independent variable, and usually that'll be the first, sometimes it's not, but usually it'll be the first of these variables listed here. So in our case, GDP per capita in thousands of US dollars, purchasing power parity. Whew, okay. Then for each of these independent variables, and also these are the confounding variables, so you can see we have here things that we think will also influence the relationship. So we have region is right here. We have the Freedom House scales for civil liberties. And we have the number of years since the last regime transition. So that's a regime durability measure. So these are all the variables we've put in that we think are going to influence this, or that we think need to control for that relationship between wealth and level of democracy. So what I'd like to draw attention to is these. So there's one of these little sets of numbers for each variable, independent variable or confounding variable, control variable, same thing. Okay, so the first is the coefficient. So that essentially means that for each unit change in the independent variable, or this particular variable, how much unit change are we going to get in this variable? So it says for here, the way we could interpret that is for 1 unit change in GDP per capita, so it's for $1,000 US. Generally, it means there's going to be about a 0.17 unit increase in electoral integrity. Now remember, we have electoral integrity on a 0 to 100 scale. So for each $1,000, we're going to get a wee little up because it's positive in terms of electoral integrity, generally. Now, there's another number underneath, and this is your standard error. This is a measure of accuracy. This number and your coefficient will help you get these little stars. Now, the stars denote what level of statistical significance, or what level of confidence. Never say what level of statistical significance. That is wrong. What level of confidence you can have. So you can see here's the little legend, and it tells me that I have 2 stars. It means that P is less than 0.05, so I can be at least 95% confident that this is not just happening by chance. Okay, so let's do another example. This is a, let's say, Freedom House Civil Liberties scale. So we know that this is on a scale of 1 to 7. So each unit increase in Freedom House Civil Liberties results in, and remember, 1 is like super free, 7 is not free. For each unit increase, we have about 7 point decrease in our electoral integrity score, which makes sense, right? Because we know that civil liberties scale is again, 1 is the best, 7 is the worst. We can see 3 stars, so we can be at least 99% confident, or P is less than 0.01. Okay? So there's a couple of other things I want to draw your attention to. One is the constant. And so this essentially means if I were to draw a line, so you know how like I have my, let's go up here, I have this line. If I were to have a line, where would I dissect, or not dissect because that would mean an half, but where would I cross the y-axis? And so here it would say it would be about 77 points on the scale. So I didn't draw mine very well at all on that correlation. But that means also though I wasn't taking into consideration all of these control variables. Something else you'll want to take a look at is the number of observations. So I have 123 countries in this. Now the reason that we had 165 originally and now we're down to 123 is because all of this extra data, all these other variables weren't available for every single country, right? So you're going to have some dropping. And if you have a significant drop in your number of cases, you should probably get a little suspicious and try to see if there's maybe another way to measure civil liberties than this score that you can get access to for all of your observations. The last thing I'm going to point out is the R-squared. All right, so R-squared essentially captures how much of the variance in the dependent variable we capture in the model. So we capture about 61% of the variance in the dependent variable based on the variables that we put in here. Now, the problem, of course, is that you can just keep adding variables and your R-squared is going to go up. So in terms of a measure of like goodness of fit, take it with a grain of salt because you could just keep adding variables and it would just keep going higher, and it could just be random variables that have no theoretical significance, and then it would be pretty crummy of you. So those are the main things, and I'm going to give you an annotated version of this that kind of labels everything so you can go back and take a look at it.